If you have a more in-depth question, of course, you can contact myself or Miss Wiley. You contact me through Miss Wiley, and hopefully I answer your questions today. But I know 16 through 18 y'all kind of worked on in class, or at least you've talked about how to get started. So I'm going to quickly go over those. So, of course, on number 16, you have to convert the 64,500,000. You have to convert that to what? Scientific notation, right? When you convert it into scientific notation, you should get 6.45 times 10 to the 7th power. Alright, so then I put my like terms together, and I get, when I do 6.45 divided by 1.5, I get 4.3. That's just one big equal sign. I get 4.3, and then I use maths, and I get 10 to the 4th power, because when we divide, we subtract our exponents, right? So I'm going to put that little subtraction sign to remind us. Okay, and so, because it's in the correct scientific notation, that's our answer. Alright, so come with me to number 17. First thing I noticed, well, it's asking at this rate, so we're going to have to multiply. First thing I noticed, this is not scientific notation. So I converted it into scientific notation into 5 times 10 to the negative 3. Why is it negative 3? All those answers sound good. My answer would have been because 0.005 is like ridiculously small, so I know it's a negative number. So now I'm just multiplying. So first thing I do is commutative property. Alright, and when I do commutative property, I put my like terms and my like values together. So 7.5 times 5, right, times 10 to the 4th times 10 to the negative 3. 7.5 times 5 is 37.5. Now, we don't want to go maths. So when we multiply, we're adding. So 4 plus a negative 3, you better have said, equals 1. Positive 1 at that. Alright, so it's 37.5 times 10 to the 1st power. Is that in scientific notation? Is that correct? No. So we have to put it in scientific notation. What's that thing we use to help us put things back into the scientific notation? If you said large, you are absolutely correct. Okay, so I'm moving my decimal to the what? To the left. So that means I have to add 1. Alright, so then I have 3.75 times 1 plus 1 is so 10 to the 2nd power, 10 squared. If I put that back into standard notation or standard form, I'm moving my decimal 2 places to the right, and I get 375. Again, if I'm moving really fast for you, you can always pause the video and go back. You can even screenshot the video and look through my work. You can, or you can shoot us a question. Alright, so this one's talking about, is this huge number. Can anyone say that number? If you said 928 trillion, you are exactly right. That is huge, ridiculous. Oh, it's not trillion, Miss Harris. It's billion. Oh my gosh. I hope you guys got it right, because I obviously did not. But it is billion. Anyway, so we're looking to see if they are combined. Alright, so when we combine something, we're adding them, okay? So we're going to take those two values. We're going to have to put 928 billion into scientific notation. So decimal goes here, and I have to count my place values to see what power of 10 I have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I should have 9.28 times 10 to the 11th power. Now what's wrong? We see our operation is adding, but are our exponents or powers of 10, are they the same? No. So therefore I have to use what? Awesome. If you said Lars, you are absolutely correct again. Okay, so what do I want to change? In this case, I changed my 11 to a 10. If you changed your 10 to an 11, are you wrong? No, it's completely fine. It doesn't matter what you do. So, if I'm changing my 11 to a 10, I have to subtract 1. And when I subtract, I move my decimal to the right. That was to the left. I'm moving it to the right. Alright, and so now it becomes 92.8 times 10 to the 10th power, right? So now I can add them. So now when I add 6.08 and 92.8, 6.08 plus 90, let me line up my decimals, 0.8, I'm going to add a placeholder right there. 8, 8, 8. So I get 98.88. Is 98.88 times 10 to the 10th, is that the correct scientific notation? Absolutely not. So I'm going to move my decimal once to the what? To the right or the left, guys? To the left. And when I do left, it says I have to add 1. Alright? So what's 10 plus 1? 11, right. So I get 9.888 times 10 to the 11th. And is that an answer choice? It is a C. So you should have gotten C. But Maya chose D. Obviously she got it wrong if the answer is C. What did she do? If you wrote down that she just went ahead and added without even worrying about her exponents, making sure they were equivalent, then you're absolutely right. What she did was she added 6.08 and 9.28, and she got 15.36 times 10 to the 11th power. It looks like she just kept the sign of the big one. And then she was like, well, this is not correct scientific notation. So she used Lars, and she moved to the left. So then she added 1. So she ended up getting 1.536 times 10 to the 12th power. And that's obviously not the right answer. Alright. Okay, so look at number 1. I'm just going to talk about, so you should underline all your numbers and keywords. The keyword I underlined was completely fill both. And that told me I was adding. So again, when I add, of course I had to change this to scientific notation. When I add, I use Lars because my exponents are not the same. I went ahead and changed this to a 4. And I changed this one to a 4. So I had to use 2 different operations for Lars. On this one right here, I used, because I moved my decimal to the left, I used the LA part of Lars. On this one, I moved my decimal place to the right, so I used the RS and Lars. When I did my operation, this is the answer I got. That's not correct scientific notation, so I had to use Lars again, guys. Oh my gosh. And then I had to use the LA part of Lars, the left add, and it gave me B. Alright, let's look at number 2. Alright, so this one's saying about how many kilometers does the moon travel during one day of its orbit around the Earth? So per day. Earlier we said, and yesterday we told that per meant to divide, right? So that's why I'm dividing these two. The biggest number goes on top. Because I can look at my place values, I see that 10 to the 6 has more place values than 10 to the first power. And so that's why. Well, Miss Harris, where did you get 2.8 from? That says 28. Is 28 in scientific notation? No. So I have to move my decimal one place, right? And I get 2.8 times 10 to the first power. Now, I can combine my like terms, and I can say 2.413 divided by 2.8 is about 0.86. Depending on how you round it or where you round it, depends on your answer. But when I rounded, I got 0.86. And because I don't want to go maths, because I'm dividing, that means I'm subtracting my exponent. So 6 minus 1 is 5. Right. Oh, but that's not in scientific notation, 0.86. So, therefore, I have to use Lars. And if I'm moving my decimal place to the right, I have to subtract 1. So 5 minus 1 is 4. Good. So your answer should be A on number 2. Alright, number 3. We have to figure out what she did incorrectly. I'm just going to tell you right off the bat the answer is B and E. And if you look closely, so if you can see, I changed this 10 to the third power to what we're used to seeing, 1 times 10 to the third power. I just converted this into scientific notation. And what happened was she added instead of multiplying first. She added her 1 and her 2 together, and she got this. That's why that's incorrect. You're supposed to multiply when you're following PEMDAS first, and you're supposed to add last. Alright, so coming down, E is wrong because, guys, she used Lars incorrectly. So let me show you real quick. If I'm changing 12 into scientific notation, that means I'm going to move left and add 1. If I'm adding 1, negative 3 plus 1 is not negative 4. It's actually negative 2. So it should say 1.2 times 10 to the negative 2 power. Alright, so for number 4 on page, I believe this is page 40, 50, whatever page we ended up on with number 4, this is the page you should be on right now. So, I got 1.5 times 10 to the 8th power. You should have gotten this when you subtract it, because it says how many more. That's the key word here. And of course, when we subtract, we take the larger number first minus the smaller number. So I have to look at my place values to know which one's bigger. Alright? And of course, you're going to have to use Lars because they're not the same. And so when you do all of that, let me write down Lars so we don't forget to use it. When I do all that, I get 1.5 times 10 to the 8th power. On number 5, both of these are correct. Because just like we've talked about earlier, you can either change your exponents into a 7 or you can change it into a 9. Either way you do it, you're both right, as long as you convert it back at the end to put in correct scientific notation. Alright, number 6. It looks hard, but I promise you, it's just what we've been doing. So I just take it step by step. So the first thing I do is I only look at the top right here. I had to use Lars